All right, let's just jump right into this explainer. We're going to look at how the actual foundational biological realities of our sex influence athletic performance and longevity over a whole lifespan. We hear a ton about training splits, nutrition hacks, and mindset, but today we're stripping all that away to look at the baseline biology. We're going to examine the physiological blueprints of male and female athletes, and honestly, the most fascinating part, how those blueprints age. So to really understand our bodies, we've got to start with this massive question. Do the engine and the chassis of male and female athletes wear down identically? Well, when we look at master athletes, those incredible folks who keep pushing extreme physical limits well into their 70s and 80s, we get this beautifully clear window into the pure biological process of aging. It basically strips away the sedentary lifestyle habits that usually muddy the waters for the rest of us. So, do we age the exact same way? Short answer, no way. But how we differ, that's where things get super interesting. To map out what we're calling this biological divergence arc, we'll hit 5 key areas today: the performance sex gap, the endocrine evolution, muscle mass versus quality, flexibility and injury, and finally, how we go about leveling the playing field. Okay, kicking things off with section 1, the performance sex gap and how this divergence evolves over a lifespan. Now, look at this. It's wild how the performance gap is practically non-existent when we're kids, right? Before age 12, the difference in aerobic capacity in running is super slim, literally just a 1 to 5% difference. But then, puberty hits. Biological males get this massive surge in testosterone, which drives up muscle mass, bone density, and hemoglobin, which is crucial because it carries oxygen. After that, through adolescence and adulthood, the gap stabilizes at around 10 to 12%. But check out what happens in advanced age. As athletes cross into that 90-plus category, the gap in running performance just blows up to roughly 30%. This is driven by some pretty severe multifactorial cardiovascular and physiological changes that hit later in life. That brings us to section 2, the endocrine evolution, essentially our body's master control system. So hormones are pretty much the master regulators of our athletic capacity. They dictate everything, from how fast we build muscle to how quickly we recover. And the aging paths here are totally different. For men, it's a slow burn, a gradual, roughly 1% annual decline in testosterone after age 30. It just slowly chips away at muscle protein synthesis. But for female athletes, the endocrine shift is a completely different story. Women navigate these massive hormonal milestones, like the musculoskeletal impacts of pregnancy and postpartum recovery. And then during perimenopause and menopause, there is an abrupt systemic cliff. Estrogen levels just drop sharply. And listen, estrogen isn't just a reproductive hormone. It is absolutely critical for maintaining skeletal muscle health. This abrupt drop takes a serious physiological toll that directly messes with a female athlete's training. Researchers surveyed highly trained female endurance runners, cyclists, and swimmers between 40 and 60, and the data is frankly staggering. Get this. 88% reported sleep problems, 83% felt intense physical and mental exhaustion, and 63% dealt with joint and muscular discomfort. When your estrogen levels fall off a cliff like that, it's not just a body composition issue. It actively wrecks your sleep, halts recovery, causes severe joint pain, and leads to a rapid drop in bone density, which absolutely skyrockets the risk of osteoporosis if you aren't actively managing it. Moving on to section 3, muscle mass versus quality, or what happens when the engine starts to decay. Okay, before we dive into the data here, we really need to get clear on the difference between the sheer volume of a muscle and its actual functional quality. See, muscle quality isn't about how big your bicep or quad looks when you wrap a tape measure around it. It's about specific force, the actual functional efficiency, and the amount of force you can generate per unit of that muscle. You can absolutely have a massive muscle that's actually quite weak because it's infiltrated by fat and connective tissue. So high mass, but low quality. And this is where it gets crazy. A massive UK biobank study looked at hundreds of thousands of people and found a very clear sexual dimorphism. Basically, older men lose the size of the muscle, while older women lose the power and efficiency of the muscle. The data showed that men lose muscle mass at a rate about 4 times greater than women in absolute terms. So men literally shrink. But on the flip side, women suffer a much more rapid decline in muscle quality, about twice the rate of males. So an older female athlete might actually keep more of her muscle volume relative to her size, but the functional efficiency, the raw power of that tissue, that gets compromised much faster. Now, let's switch gears to section 4, flexibility and injury patterns, essentially the chassis of our bodies. So,
Looking at data from over 27,000 GOWOD mobility assessments, we see that women consistently outperform men in the shoulders, scoring 71% compared to the guys' 65%. That is huge for things like overhead strength or swimming. Women also take the lead in hip mobility. Now, guys do manage to squeak out a tiny little victory in ankle mobility, 78% to 76%, which helps a bit with squat mechanics and running. But there is one specific area where the gap between men and women is just absolutely staggering.
14%. That's the massive gap in posterior chain mobility, we're talking hamstrings and lower back, between young women and young men. And honestly, it perfectly explains why male athletes are constantly complaining about lumbar tightness. Across every single age group they tested, men scored the lowest in posterior chain mobility, usually by a mile. This lines up perfectly with what we see in clinics. Tight hamstrings, terrible hip hinge mobility, lower back tension. These are overwhelmingly male athlete problems. Women naturally just have greater baseline flexibility because of structural and connective tissue differences. And actually, this natural laxity gets compounded during and after pregnancy. Hormones like relaxin flood the body to literally loosen ligaments for childbirth, which permanently alters pelvic mechanics and means women need highly specific stabilization training postpartum. But catch this, while all that flexibility protects women from the tightness guys get, it's a double-edged sword. It makes female athletes way more prone to overextension injuries or degenerative joint stuff like meniscal tears later down the line. All right, let's wrap this up with Section 5, leveling the playing field, and how training acts as a great equalizer. So while our biology definitely sets these overarching trends, let's talk about how our behavior, specifically our training, can bridge that physiological divide. Researchers did this brilliant study. They took fit male and female recreational cyclists, matched them identically by body weight and their exercise volume. We're talking people cycling over 7,000 kilometers a year, and they literally looked inside their glute muscles with an MRI. They were hunting for intramuscular fat. That's the fat marbled inside the muscle that ruins muscle quality. Since females generally carry a higher body fat percentage and tend to store more subcutaneous fat around the hips and pelvis, the researchers wanted to know, did their muscles reflect that? And here is the major aha moment of this whole explainer. Despite all those hormonal differences, and despite the female tendency to store more subcutaneous fat, identical training literally erased the differences in intramuscular fat and relative gluteal muscle mass. The MRI showed that underneath the surface layer of fat, the actual engine, the muscle tissue itself, was essentially identical in quality and relative size between the men and the women. That is a profound finding. It proves that yes, your biological sex sets your baseline, but rigorous, targeted training can actually overwrite so many of these physiological assumptions. So to fight back against these inevitable biological declines, the research heavily supports a few specific interventions to keep you functioning at a high level well into your 80s and 90s. First up, you've got to target your type 2 muscle fibers with heavy resistance training and explosive movements. This is critical for everyone, but it is absolutely vital for female athletes trying to preserve that rapidly declining muscle quality and power we talked about earlier. Plus, heavy lifting is non-negotiable for women fighting to maintain bone density post-menopause. Second, up your protein intake. As our hormones drop off, whether it's the slow fade for men or the sharp cliff for women, our muscles become anabolically resistant. Basically, they need a much louder protein signal to trigger repair. And third, you got to do consistent, targeted mobility work. For the guys listening, that means relentlessly attacking that 14% deficit in your posterior chain to save your lower back. Ultimately, while chronological aging is totally non-negotiable, the rate of your functional decline is highly plastic. It really leaves us wondering just how far we can push the limits of human longevity. The divergence in how male and female bodies age is undeniably written into our DNA and our endocrine systems. Men are going to face that slow erosion of muscle mass. Women are going to navigate the massive structural shifts of motherhood and the sudden drop of menopause. But just like those elite cyclists proved, the ultimate architect of your physical destiny isn't just your biology, it's your behavior. So, armed with all this data, how are you going to adapt your training to outsmart your biological clock? Take these insights, apply them to your routine, and keep pushing your limits.